Okay, now we're graphing systems of inequalities. Note, the very first thing I want you to pay attention to is note whether you're going to need to draw a dashed line or a solid line. You draw dashed lines when the inequalities are greater than or less than. You graph solid lines when they're greater than and equal to or less than and equal to. So in the first equation, notice the yellow highlighted one, that there is a less than. We know right away that's going to be a dashed line and a hollow dot at the y-intercept. So I'm going to go ahead and do that now. So you're first going to graph, I'm going to first graph the yellow highlighted one. The y-intercept, remember, y equals mx plus b. You're going to at least start to graph it like it's an equation, but it's a little bit different. So I'm going to put a hollow dot at 1, and then the slope says that it is 3 over 2. Well, remember, rise over run, and since it's positive, you're going to go up 3 over to the right 2. So 1, 2, 3, 1, 2, and I'm going to put another hollow dot. Now I'm going to also go backwards, so I'm going to go down 3, 1, 2, 3, backwards 2, 1, 2. That way it's easier for me, it's easier for me to, I'm going to make this a dashed line. To draw the line. All right, now I'm going to go ahead and do the green highlighted, and notice it is less than or equal to, so it will be a solid dot and a solid line. All right, and this time its y-intercept is at -3, so down here at -3, I'm going to put a solid line, and this time the slope is -1/2. So since it's negative, we go down 1 over to the right 2. So I'm going to go down 1 over 2, and I'm going to put a dot. Now I'm going to go backwards. I'm going to go up 1, back 2, and then up 1, back 2 again, and now it's going to be easier for me to draw, this time, a solid line. There you go. Now, there is an intersection point, but when it's inequalities, it's not just the point that needs to be noticed, and this point is -2, -2. But what you need to do is graph each of them, or shade each of them. So, let me come back up here. We noted which type of line, we marked the y-intercepts, we graphed the lines, dashed or dotted, and now we're going to shade. And this is kind of the tricky part, but I'm going to hopefully walk you through it and you'll know what to do. All right, so let's come back, bring our focus to this. This says y is less than. Well, as you're looking at the y-axis and you're looking at where it touches the y-intercept at that hollow point, where are y's smaller or less than? Are they smaller above or below? Well, above is 2, below is 0, so the y's are smaller. So we're going to shade this entire side of that dotted line. This means that y is less than or equal. Now I'm going to pick the green shade, and this says y is less than or equal. So we look at the y where it's at the y-axis, where it crosses the y-axis, and again you ask yourself, where are the y's less than or smaller than? Well, up above is -2, down below is -4. if you're looking at a number line, numbers get smaller or more negative as they move left or as they move downward, and so we're going to shade. And notice I tried to go in a different direction. And where they overlap, this is the solution set, and this is how you check. Some people like you to check at least two spots, one inside the area that's a solution and one outside. So if you check outside where they're both shaded, make it easy on yourself. Check U0, 0 for, so right here we're going to put 0 in for Y, 0 in for X, and this would now say Y is less than, well, 3/2 times 0 is 0. Y is less than 1. Well, that is true. Well, that makes sense. 0, 0 is under the yellow highlighted. Let's see if it works for the second equation. 0, negative 1/2 times 0 is 0. 0 subtract 3 is negative 3. Is 0 smaller than negative 3? False. Now we can check one down here. We can also make it easier on ourselves. Let's check negative 4 and 0. So Y is negative 4. 3/2 times 0 plus 1. So that ends up being negative 4 is less than or equal to, less than 1. Well, that's true. Let's try the other equation. Y is negative 4, less than or equal to negative 1/2 times 0. Because remember, we're using this point right here, which is negative 4, 0. Y is negative 4, X is 0. Minus 3. So negative 4 is less than or equal to negative 3. That's also true. So we graphed that correctly. So we tried a point on the outside. One was true, one was false, so it doesn't work. It doesn't satisfy both inequalities. Then we tried a point where they're both shaded, and the solutions fit both of them. They're true. That's it.